This is Geometry Section 3.4, problem number 9. And we are trying to prove that two overlapping triangles are congruent. We have triangle PLN right here. And we also have triangle MLO overlapping with it on the outside right there. So we need to find some way to prove that those two triangles are congruent. One of the things I like to do when you have overlapping triangles is draw those two triangles out separately so that as you find parts that correspond, it's a little bit easier to mark up your diagram, because this diagram is going to get really messy really quickly if we just leave it as it is. So we have PLN, and I'll just quickly relabel that, and then we have MLO. And the reason that I do this is every time we find things that are true up here, we can mark them true down here. So let's mark our given information now. We have POL and MNL. POL is actually this marked one right here, and MNL is this marked one right here. Now, neither of those fall on one of the corners of our two triangles that we have right here. So those don't actually directly help us at all. So let's move on to the next one for now. PO is equal to NM. PO and NM are equal. Once again, these don't form a complete side. They only form part of a side. So that really doesn't help us down here either yet. So it'll be something on the way to helping us, but doesn't directly solve our problems. And then finally, PL is equal to LM. PL is equal to LM. Finally, that's something that we can actually correspond to down here. So we have two sides that are equal in the two triangles we're trying to prove congruent. The rest of this stuff doesn't directly solve our problem yet. So let's get down our given information and mark it as given. Before we go the rest of the way, we need to find some way to get some other sides or other angles that are going to help us out. My thought looking at this diagram is that I can prove that this short side, ON, is going to be equal to itself. And the reason that's useful is not because it forms a full side down here, but because of the fact that if I add this little part and this little part, it should be the same length as this little part and this little part. The red and the black over here should be equal to the red and the black over here. Meaning that if I can find a way to prove that and write that all out nicely, PN and NO, or PN and OM, are going to be equal to each other. So I should be able to prove that this side and this side are equal. But that's going to take a couple steps, so we'll get to that in a moment. If I can do that, I'm going to have two sides. I'm going to want an angle in between them. So somehow it would be nice if I could prove that P and M are equal to each other. Taking a step back from this triangle up here, looking at the big picture, I see a triangle that has two sides that are the same length. And when you have two sides the same length, you're looking at an isosceles triangle. Conveniently, isosceles triangle also have two angles that are the same down here at the base. So that means that angle M and angle P are going to be equal if we have an isosceles triangle. And those two angles would correspond to down here, to these being equal down here. If I can find a way to prove all those pieces I just said, I'm going to have side, angle, side, side, angle, side, and I'll be able to prove congruence using that. So let's go ahead and try to write this all out and see where we can formally do this. We'll start with the isosceles part where angle P is equal to angle M. So we have angle P equal to angle M. And the reason we can do that is by the isosceles triangle theorem. So isosceles triangle theorem, we can go ahead and just write that out right there. That proves that P and M are equal. Those are the ones that we marked right here. The last thing we want to prove is that PN and OM are equal to each other. And in order to do that, we need to do this in a few steps. ON and NO because we're going two different directions. One we're coming this way, one we're coming this way. ON and NO, which are the same line segment, are going to be equal to each other. And that's going to be step one. So ON equals NO. And that's by the reflexive property. That doesn't get us all the way there, though. We still want to prove that these larger sides, PN is equal to MO. To do that, let's do parts to whole. Let's take the two parts. We know that PO plus ON equals PN. PO, short segment here, plus ON, short segment here, equals PN, the larger segment. Along the same lines, we can also say that MN, coming from the other direction, plus NO equals PO. So now we're going MN and NO equals, typo, MO. MN plus NO equals MO. That doesn't prove that these two things are necessarily equal to each other, though. We can use substitution to make that step. So before I get too far, let's write parts to whole here. Parts to whole. And our fifth step is to use substitution to prove that these things are equal. So if we take PO, which is equal to MN here, and we substitute that out, then we could say that MN plus ON equals PN. The reason I did that was PO right here is equal to MN right here. So I just substituted and rewrote that first statement. I also know that NO and ON are the same, so I can, by the reflexive property, so I can go ahead and just write it like that. And what I'm slowly starting to do is MN plus NO equals MO, MN plus NO equals PN. I did substitution. Last step down here is to do a second substitution where I take this entire side of this equation, Mn plus NO, Mn plus NO, they're both the same, so I'm going to therefore say that MO equals PN. These two parts are the same, these two parts have to be the same. So MO equals PN, again by substitution. Because I've now proven that those two parts are equal to one another, I now have enough information to say side, angle, side, side, angle, side. And I can prove that these triangles are congruent. So I'm going to go ahead and write my congruent statement right down here at the bottom. I have triangle L, start at the top, LPN, go top and go outside, is congruent to triangle LMO. LMO. And let's mark this properly here. Triangle congruent to triangle. And then step 7 down here at the bottom was by side, angle, side, SAS. And we are done.